Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the life cycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host as usual is Tobias Macy, and today I'm interviewing Joey Faulkner about Rasa Core and Rasa NLU for adding conversational AI to your projects. So Joey, could you please introduce yourself?
Hi, yeah, I'm Joey, and I do AI research for Rasa.
And do you remember how you first got introduced to Python?
I do, because it was actually surprisingly recently. So it was maybe 3 years ago when I was just starting my PhD, and I just turned up on my first day. I hadn't done much coding before, and my supervisor was like, yeah, we're going to be working with simulations, so you're going to have to use this thing that's known as YT, which is like this awesome simulation library that's like really clever, very Pythonic and awesome, and I had no idea what was going on. So I think I spent the first 3 weeks trying to work out how to pip install stuff because I was so useless. And so it was it was kind of a trial by fire. And like looking back, the way I approached Python was like in a way where I was being very stupid about it, and I probably should have just read something before I got started.
Well, there's something to be said for just jumping in feet first and seeing what happens as you go through it.
Yeah. I think that the one moment that sticks with me is when I went to my supervisor and I was like, "Oh yeah, this thing isn't, my code isn't working unless I run it in sudo," and he was just like, "What?" Like it just didn't make any sense. And so I still have no idea what I was doing back then. But yeah.
And so, as we mentioned at the intro, you're going to be talking to us about the work that you're doing at Rasa Technologies. And so I'm wondering if you can just start by explaining the goals of Rasa as a company and highlighting the projects that you've open sourced in the pursuit of those goals.
Yeah, absolutely. So broadly, what we're doing at Rasa is making conversational AI, which a lot of people know as chatbots. And our goals are to, firstly, what we want is to have a set of libraries such that people, of open source libraries, such that people can make their own chatbots and see what's going on all the way through the process of making a chatbot. So all the way from text to actions produced by the chatbot. People can see exactly what's going on with their data. But more broadly, we want to make software that can actually produce like real conversations, because we looked at the market and at what was being used by a lot of companies, and we thought that actually like there was a way we could step forward with this.
And so the two projects that are at least being promoted on your main website are Rasa Core and Rasa NLU. So I'm wondering if you can just do a brief rundown of how those two libraries relate to each other and what are the reasons that somebody might want to use one over the other.
Absolutely, yeah. So actually, Rasa Core and Rasa NLU feed into one another. So as I said before, what a chatbot does is essentially go from text to actions. And the pipeline for doing that is you start off by sending your text into Rasa NLU, the NLU standing for Natural Language Understanding, where the text goes, it's classified into an intent and entities. So for example, if you were talking to a weather forecast bot, you could say something like, what's the weather going to be like in Scotland tomorrow? And the intent there would be to request for the weather. That would and you also get entities, which are bits of information that the user's trying to pass to the bot. And in that case, you'd have like location being Scotland and the date being tomorrow. So that's Rasa NLU. Basically, we're providing an open source framework to go from the text to the intents and entities. But then Rasa Core is what we know, what we call as the dialogue manager, which goes from these intents and entities to the actions. So in this really simple case of the forecast bot, it would take the fact that you're requesting the weather and the entities, and it would do a series of actions, the first of which being something like querying an API, saying like, what is the weather in Scotland tomorrow? And if it got a successful return, then it would commit another action, which would be like, tell the person about what the weather is going to be. So message back. So basically, between Rasa NLU and Rasa Core, you have the full chatbot framework to make a bot.
And just stepping back a bit, just to do a sort of high-level discussion of chatbots in general, what do you see as the main driving force for the popularity of that particular sort of style of technology? And what do you think its main benefit is to people who are using them?
I think there are two reasons why chatbots are becoming so popular at the moment. And the first of which is just technologically, it's now possible to do things that even 5 years ago seem to be impossible. Like in machine learning, there have been a lot of really great step forwards. One of the biggest being word2vec, which is it's a way of creating sort of like meaning out of words without having to have a very like explicit definition of how language works, which is awesome. So I think the first part is just the capability of making these chatbots and making them work well is one of the reasons why this has become so big recently. But I think secondarily, just how much people use messenger apps now compared to like 5-10 years ago is like huge. Like most of the capabilities of somebody's phone are used in Messenger. So before, when you were like, oh, I need to make a website because everybody's on the internet, on Google Chrome and stuff, that made sense then. But now, since everybody's talking on Facebook, Messenger, and stuff like this, like you can see where the people would want to move into chatbots, as it's a very natural way of doing user experience. So instead of somebody going onto your website and trying to work out how to do something by how you've designed it, and something that may seem really normal and obvious to you, like clicking through menus and stuff like that, may be completely alien to someone else. But through natural language and just requesting things from a service is much easier. It's much more natural to just ask a service a question than to try and use its own interface, I suppose.
Yeah, and as you said, one of the main reasons why it is feasible today is because of the fact that we do have these machine learning algorithms that are able to make it feel natural when you're conversing with these bots, because previously, if you wanted to be able to interact with, a textual interface to a program, it was either via the command line, or you had to memorize a very limited set of inputs that the bot would be able to understand in order to be able to get a useful output. Whereas with the word2vec algorithm that you mentioned, we now have the capability of being able to do semantic matching between the intent behind what that person is trying to do, even if they aren't phrasing it in the exact structure that the bot is expecting, or using the exact same words as what it was originally programmed to accept as an input.
Yeah, absolutely. So I think, I don't know if people would agree with me, but I think that word2vec has had like a huge impact on NLP in general, specifically in chatbot in the chatbot space. It is really awesome to see what you can do with it.
And we've started to briefly touch on how the interaction model changes when you're going from a traditional conversational bot framework that uses state machines to determine where you are in a conversational flow. And just curious how that particular interaction model changes when you bring in the capabilities of Rasa Core.
Basically, the way, when we were starting out, we were looking at sort of like dialogue managers and what the state of the art was, and what a lot of people use are these state machines which have you in a set of discrete states. So say if we were in the weather bot state, let's stick with the weather forecast example. So you would start off in the greet state, where if you said hi, then the bot would say hi back. And then if you asked for the weather, then you'd move into a new state, which was the weather state. And now you're talking about the weather and stuff like that. And basically, we didn't really think that this is how conversations work. Like if you and I were talking about about this, then now we're in the Python state. But if we were talking about sports, you'd ask a question about sports, now we're in the sports state, but we'd forget that we were ever talking about Python in the first place. So and basically, we were just like, it's not really how conversations work, and we want to create something which has the capacity to have real conversations. I mean, without getting too into the details, we use what's known as a recursive neural network, which, deep learning is used for everything now, but it's essentially like a deep learning platform with which what we do is we scan over the entire conversation you have with the user and try and predict the next action, not only through what the person has said, what the other person has said to you, but also the history of the conversation. And sometimes it won't be relevant and sometimes it will be. But what it means is that, firstly, you're never having to just sit there and define what the conversation can be. Like, what are the finite states of this conversation? Which is good, because you just have to think, right, well, how should the bot respond in this certain state? And it'll then learn, like, around that, what the actions are as a function of what your history is and what the person has said. But what it basically means is that we don't have to have these linear interactions with users where it's like, okay, now tell me this, now tell me that. The bot can learn to go in different ways and to have sort of like a more conversation, more of a real conversation sort of thing. But one of the things that we think is really awesome about the fact that we've now transferred this into recursive neural networks and neural networks in general, is that instead of having to define the state machine before and like define what the conversation is, what you can do now is, instead of having to teach the model by telling it what the state machine is, you can teach the model simply by speaking to it. So say you say hello to it, it'll come up with a prompt and say, the bot thinks that it should say hello back. Should it? Yes. And you respond yes, and then it'll update the parameters of the model such that it gains more confidence in how it should respond to users, which is basically a way of bootstrapping training data. So instead of ever having to fully define what the bot does, you simply teach it to do stuff by instruction, essentially, on the command line.
And so it sounds like it's using a very interactive supervised learning model where, rather than having to necessarily feed it a labeled data set of training information, you just proceed through the conversational flow that you're trying to teach it to be able to support, and it just is able to then curate that information and feed it through its neural net to train the model at that point. But one of the things that I'm curious about as well is, in order for it to even understand what an appropriate prompt is at the beginning of that interaction flow, do you ship a sort of rudimentary model with the library so that you have some sort of starting point, rather so that it doesn't need to start from ground zero of not necessarily even understanding what what language is and what a conversation is supposed to look like?
Yeah, absolutely. So basically, what we do is we ship a few examples of like how people would make these bots, like just as most libraries do, just in the examples folder. But yeah, I should have also said you define sort of like the domain of things that your bot can do. So you have a set of actions that you can write yourself, such as like a query API action or like a response action. And then basically from this domain, all you're doing is you're telling it what actions it can do, what intents it can handle, what entities it should have, and these and what slots it should have. And what these slots are just a way of storing information in the bot. And basically all of these things that I've just said, the intents, actions, entities, and slots, all go in as features of the neural network. So after you've defined those four things, that is the point at which you start bootstrapping training data with the online learning model, as we call it. So then at that point, you can start teaching it by instruction.
And in order to be able to parse the natural language input, my understanding is that you're leveraging libraries such as Spacey under the hood. Though looking at the documentation, it appears that you can swap that out for some other alternatives. So at this point, it would be good to do a bit of a deep dive on how the Rasa natural language understanding and Rasa core libraries are implemented, and maybe talk about how that design has evolved as you have continued to work on and update and improve the libraries.
Yeah, absolutely. So to start with, Rasa Technologies had sort of like one model where we said, okay, we'll take the word vectors from I think we started on Spacey, but it might have been MITI. I'm not sure, but it would just be like, okay, so intent classification specifically is what. Well, actually, no, for both of them. So to start with, you would take your word vectors from Spacey, let's say, and you would just do intent classification using a simple classifier from scikit-learn. But there are a lot of cases where that doesn't work out perfectly. So, for example, we wanted to make it good for German speakers to use Rasa as well, and that's fine in the sense that there are still word vectors for German, but there's a unique problem with, well, I don't know if it's unique, but it's not a problem in English language, which it is a problem in the German language, where there are these horrendous compound words where they'll take like 4 or 5 words and jam them together into one word. And of course, since that word will just not appear much in training data, they won't end up having sort of like converged word vectors for that, which means that you'll lose like a big part of a sentence, which will normally be a really important part of the sentence to classify what people are trying to talk about. So what we did, and what is sort of what it sort of this is just sort of an example of how we're trying to change how we've changed the design of it, is by implementing a module which looks for a series of letters within these compound words and then uses them as extra features onto the classifier. But yes, a lot of people won't need that. So what we decided to do was make it a lot more modular, and it's such that you could say, okay, I want these features, but I don't want these other features, by sort of and like defining a pipeline out of all these features. But what this allows us to have is a library where people can make their own featureizers and add them in, and it all works much more smoothly. So I guess sort of like having the fluidity of people being able to define their own modules of Rasa NLU is definitely a big part of how it's changed.
And in the documentation, it calls out services such as wit.ai or Lewis or Dialogflow as sort of the main contenders to the capabilities that the Rasa libraries provide. And so I would just like to see what are the motivations for somebody to use the Rasa libraries instead of one of those hosted services for being able to provide that conversational interface to their projects.
Mm-hmm. So, I mean, like there's the first reason, which I'm sure a lot of your listeners will agree with, of like just having things that are open source is generally like pretty good and pretty cool, but that's not that compelling a reason, I understand. But for me, who's somebody who comes from a machine learning background, like it would be very frustrating, like black boxes in general, like things that you put in, things where you put in data and you get out an answer and you don't know what it's doing, are incredibly frustrating, because if they work well, that's fine, and you just carry on with your life. But as soon as there's an error in it, or you think there's an error in it, there's nothing, you can't do anything about it. It's not like you can go halfway through the wit.ai or Lewis classifier and say, okay, so why is this sentence not being classified badly? So that's one of the main things. We thought we could bring a service where people who wanted to know wanted to debug their sentences would know why these things were going wrong. But I also think that it's kind of I don't want to call it a scam, but it's of scam level, like, because you have when you're using something wit.ai or Lewis or something, the first thing you'll do is you'll send them a bunch of training data of sort of like sentences and intents and entities, and you'll give it to them and be like, okay, now make me a classifier out of these things, and for the first part, it'll be free to you, and as long as you stay under a few queries per, I don't know the exact limits, then you'll get this all for free, and that's fine. And then you'll start paying when people start using it in production. But it's kind of a scam, because you are giving them stuff that's worth value anyway. Like one of the most expensive things in machine learning is labeled training data, and you're giving them all of your training data and for nothing, and for a service which there was a paper out recently that if you talk to anyone in our company, they'll tell you about, because we were ranked. We came second out of 4 where they used these API services in terms of our recall. So if I was Amazon or Google, or then I would say to you, well, the reason why we keep your data, our closed source, is because we have proprietary algorithms, and we don't want to show what we're doing because that's where our worth is. But in fact, we've shown that with our model, which you can literally Git clone onto your hard drive, and we can never take it away from you. You can get similar, if not better, results than a lot of these API services. So yeah.
Yeah, the factor of being able to control your data is definitely a big win in terms of virtually any service, particularly when you're trying to deploy this in a business context, because customer data is one of the most valuable differentiators that you can have. And there was a podcast I listened to a little while ago that talked about the concept of data capital and how that's becoming one of the biggest differentiators as we continue into this new era of artificial intelligence and machine learning, because that's what allows you to leverage your relationships and your core competencies into something that your customers are actually going to want to use. So being able to have an open source tool chain to be able to collect and improve with the data that you're receiving is definitely highly valuable. One of the other things that got called out in the documentation is the fact that by using one of those services, you're sort of forced into using the generalized conversational models that they're using, because they have to be able to support such a wide variety of use cases. Whereas with Rasa, because you know exactly what it is that you're trying to do with it, you can create a more finely tuned model based on the training data and the interactions that you're using within the context of your project. And so a little earlier you mentioned that one of the most expensive aspects of building and deploying a machine learning system is in obtaining the labeled training data. So I'm wondering if you can just talk about some of the biggest challenges that users of the Rasa libraries are facing in terms of being able to collect and curate that data for being able to build the models that they're going to use within the Rasa libraries.
Yeah, so it's actually very human things which are the biggest problems in trying to get this training data. So I know personally that I'll be making a bot, and I'll be using the sort of like training interface that Rasa Core has, at where you type a message, it classifies the intent and entities, and then you go through the actions like that. And it's very sort of like addictive. You just keep going, and you try typing things in different ways. But the way I think about saying something, especially textually, is very different to how other people would, and that's true for everyone. So you can be training your model, your bot, for ages, and then somebody else can come along and type a message, and you'll be like, oh, I'd never say that to mean that, but a user would. But we obviously the way that Rasa NLU and Rasa Core are designed is to generalize across sort of like how different people speak and different people say things. So I think generally the biggest challenges you'll have is having conversations with people who aren't you with the bot, sort of thing. So generating NLU that comes from people who aren't so close to the project, because this has the problem of, if your bot isn't working properly, then you can't just get somebody new to use it, because if it has a bug, they're like, oh, I don't know what's going on now. But one of the ways that you can get around this is something that we call sort of like Wizard of Oz, and the way you can generate training data and sort of debug your conversational script, even though it's not a script, as otherwise we'd just be using a state machine, is where you find a new user, and the user sends messages, but on the other end, instead of there being a bot, it's just you. So you you pretend to be the bot, but through text. And it works in a couple of ways. So first of all, you get new NLU data, which is very valuable. But also, it's if you truly like restrict yourself to the domain of I can do this action, I can do this other action, and you find that when somebody says something, you don't know what to do with it, then you've either realized the limit of the scope of your bot, or that you need to extend your domain. So that's one way of getting around this curating this training data.
And so when you have a system that's running already and you encounter one of those sort of colloquialisms or speech idioms that is unfamiliar to the bot, is there a way for being able to flag that as misunderstood input so that you can then store that in a system to be able to go through and classify for being able to feed back into the training set?
Yes, at different stages. So if you have your bot in production, then you have to sort of like go through conversations and say if there was a problem, you look through it and you say there was a problem here, and then you put that back into the NLU data and stuff like that. When you're putting the bot into production, it isn't quite as simple, because the bot is just simply operating, and the bot classifies intents and entities and does actions, and sometimes those actions will go wrong. But our hope is that users, sort of developers, would have a testing mechanism in place that you wouldn't go ahead and make your bot public before testing it on sort of like 10 to 100 people who haven't used it before. And you can go through their conversations and say, right, did this go okay? Did this go wrong? Sort of thing. So sort of like a soft launch. And then you would fold that back into your NLU and your core data and sort of like debug what the problems were there. But at the stage when you're first starting and developing it, even just on the Rasa core command line interface, it'll tell you what it believes the classification of certain text is. And you will then sort of like have to tell the bot that no, that was wrong, and it'll automatically go into NLU training data, which you can then use to update your model.
This is one of the cases where having a machine learning or AI-driven conversational system can be more beneficial than, for instance, the state machine, is because it provides you with more ways and more opportunities for being able to surface to the user that you didn't understand what their input was. Because if you're using a state machine and somebody enters a command that is completely out of the bounds of what the state machine was programmed to be able to handle, then there's a good chance that it will either just get into an unknown state or just become unresponsive. Whereas with the conversational AI, if somebody's saying something and it's not able to properly classify it, then you can then program the bot to just come back and say that to the user, to say, I'm sorry, but I don't quite understand what it is that you're trying to ask me for. Can you please, rephrase it or something, so that you can at least then continue the flow of the dialogue, and the user, might not necessarily have the optimal experience, but they're at least getting the feedback that whatever way that they're asking a question or issuing a command isn't understood by the bot. And then later on, you can then take that data and then feed it back through, so that in future, those particular speech idioms can then be incorporated into the system.
Right, exactly. Yeah.
One of the other big challenges when dealing with any sort of conversational interface is being able to support multiple languages, particularly given that a lot of the work being done in this space is generally fairly centered around English language input. So I'm wondering, what are some of the biggest challenges that you faced on that front, and what are some of the ways that you're working on supporting additional language inputs and conversational capabilities for the bot?
So it's a great question, and it is part of the reason why Rasa NLU is why we've split it into Rasa NLU and Rasa Core. So the idea is that since we're going from text to intent and entities in Rasa NLU, the intent and entities should be sort of like invariant to what language they're in. So the transformation from text to intents and entities is definitely very language specific. But when you go from intents and entities to actions, that should happen the same way no matter what language you're in. Is the idea, but obviously you can change that if that's what your bot needs to do. But yeah, it's a great question, and the way we designed Rasa NLU, which leverages very very much the word vectors, is that essentially if subject to a pull request, you can just implement a new tokenizer and load some word vectors, some converged word vectors from the new language, and the intent classification and the entity recognition should work very well at that point. So especially languages that are sort of like similar to English and German and stuff, it should work out of the box with these new word vectors. But we're trying to make it sort of more general, looking at sort of languages that don't follow this the same sort of like patterns of words as tokens as what sort of English and German stuff does. But it's obviously very hard, and there is sadly a very small amount of research in those areas. But it would be an awesome space to get into. So I really hope that.
And what are some of the biggest challenges that you have been confronted with, both in the history of the Rasa project and things that you're facing currently and into the future, as far as being able to build and improve on the tools that you're creating and the sort of growth of the company and the pursuit of its goals?
So the main, I think one of the problems we've come up against is, at least in the past, was people seeing, the big names, sort of like IBM, Microsoft, Google, all of them producing these APIs, and then this sort of like tiny company of 10 people, and then they're just like, okay, so why shouldn't I choose the first three, and why should I choose this sort of like small company? And to start with, it was like, come on, surely these guys' product isn't actually like at that level. But it's over time, sort of like through our users, but also through sort of like the academic research of people of Rasa and these other APIs. It's kind of started to show that we can compete with the big companies, and we're sort of like approaching things in cool ways. So yeah, so firstly, building that trust that we have a good service. That was a problem in the past. I think people are starting to believe, but for now, I think sort of the problem we face is sort of reaching more developers and saying, look, this is like legitimate. We are giving you chatbot software where you can develop it yourself, you can fork it, and you can make it private. We actually just want people to use it, and trying to communicate to people that we have an awesome product and that they should use it, but at a developer level, not just at the sort of like the corporate level. And trying to build a we have lots of contributors on Rasa NLU, which is like super awesome, and we have like a really active Gitter community, which is great, and part of the reason why we love being open source. And trying to move that onto Rasa Core as well is a interesting problem, because sort of Rasa Core isn't the most standard way of approaching dialogue, but we think it's really great, and we think that if people start using it, they're going to want to keep using it.
I've done a number of shows in the past about different projects that have a conversational component to it, whether it's via text interface, such as Opstroid for being able to interact with your systems infrastructure, or Calliope and Mycroft for providing a voice-oriented personal assistant capability. And I'm wondering what would be involved for those various projects to replace the dialogue components of their systems with the capabilities that Rasa provides, and what would be the benefit to the end user by for those projects to take that step.
Specifically on the voice activated, this is sort of an active research area for us, because we have been focusing Rasa NLU towards like actual typed text to action. So there are a lot of extra problems that people have with voice classification, because there are stutters and there's ers, and that there's a lot more scope for misclassification of words. So it's definitely an interesting area that we'd like to look into. But yeah, for now, I'm not 100% certain how Rasa NLU would cope with a voice to text to actions transition. But it would be really interesting to find out. But again, part of the reason why we split up Rasa into Rasa NLU and Rasa Core is that if Calliope or Mycroft have a sort of like voice to intent pipeline already in place, then what we can offer is sort of like a dialogue manager which doesn't have to have explicit states and which can be simply trained by instruction, which can lead to sort of like much more non-linear and interesting conversations that people could have with the voice assistant. So we'd obviously love it if they got involved. And and Obstroid, I haven't looked at the specifics of Obstroid, but again, we can offer an NLU service which interpolates really well over different text and can learn with a small amount of training data, and again a dialogue manager which can handle sort of like interesting conversations and conversations which aren't just sort of like intent to action, sort of like build up a history and build up a real actual conversation.
Yeah, one of the things that came up in particularly the Obstroid as well as the Calliope conversations is the difficulty of maintaining context in an interaction with a user, because particularly the bots that are focused on group chat interactive capabilities are generally just keyword or regular expression driven, where it's you issue a command and then it either takes an action or issues a response. And that's essentially the end of the interaction with the bot. And so being able to provide context and create a continuous dialogue with a user so that you can get a much richer interface and experience is one of the challenges that is currently presented with the general way that those are being implemented. So it definitely sounds like Rasa NLU and Rasa Core for being able to maintain the flow of the conversation and not necessarily have to do it via a state machine or explicit state would definitely be a big win for those projects.
Yeah. Well, it would be it would be totally awesome if they used it. And if you're listening, feel free to shoot me an email, because it would be really cool if we can get Rasa Core helping run these bots.
And on the comparison page on the Rasa website for comparing the hosted Rasa platform with the open source capabilities, it mentions one of the features as being the collaborative model training. So I'm wondering if you can just describe a bit about how that works and what are some of the reasons that somebody might want to take advantage of that as opposed to just running it self-hosted.
Yeah, absolutely. When we're looking at sort of like commercial applications of Rasa, the amount of training data that's required is generally massive, because not only are there a bunch of intents people want, but there are loads of sort of like but the conversations are more complex, and also the room for error is much worse. Like if you get something wrong, it's like a actual cost, and that really sucks. So we're trying to make it a lot easier to create this training data. So we create interfaces for people to use Rasa and train Rasa, even if they're not a developer. So we don't only have to have sort of like Python programmers teaching the bot how to work, or sort of adding intents, adding entities or actions and stuff like this. So that's what we kind of mean by collaborative model training, that we can have a bunch of people all sort of like side by side trying to improve the model and improving the model as they go, essentially.
And one of the things that I was curious about as well is when you are running Rasa embedded in a particular application, particularly for things such as Calliope or Mycroft that are intended to be run on a Raspberry Pi, I'm wondering what are the limitations that Rasa can handle in terms of system resources while still being able to run at an acceptable level and acceptable level of expressiveness.
Mm-hmm. So In terms of Rasa NLU, there is quite a a largish memory requirement through Spacey, simply just because of the library needing to have access rapidly to every word vector. So you have about 2 gigabytes of RAM taken up as soon as you load Spacey, which you will do with Rasa NLU. But I presume they have the same problem anyway. But yeah, in terms of Rasa Core, it's incredibly light. It's a Keras model with typically the weights will it isn't as deep as the deepest neural network can go. So like just simply the storage of those weights and the architecture is actually very low. So an implementation of Rasa Core shouldn't hog the resources too much.
And what are some of the most interesting or unexpected uses of the Rasa libraries and toolchains that you've seen?
I actually just came back from a Python conference in PyCon DE in Karlsruhe, and I was talking to somebody afterwards about after a talk I gave about Rasa tools, and he told me that he was using Rasa to sort of like run a chatbot which helped HIV patients in South Africa get from their houses to sort of like the doctors and HIV clinics and stuff. And I just thought that was like really awesome. Like it's super cool that since we have this open source framework and like we don't expect people to pay for their usage, they feel like they can do charitable stuff with it. And sort of like the fact that this person was like we were enabling this person to do something which was so charitable and so useful for his local community was really, really great.
Yeah, that's definitely one of the great things about open source in general is the amount of leverage that it can provide with a minimal amount of investment, particularly monetarily, and the ways that people can use that to improve their communities and themselves.
Yeah, absolutely, and that's one of the reasons why I got involved with Rasa in the first place, because I like most of all when sort of like we're working really hard to getting something out there, and it's just like what's the point? But it's just like we want this software to exist, and we want people to have the ability to use it, because AI is kind of scary. Like there are a lot of things that AI can do, which kind of scare people and can really change the structure of our society. And the idea that the capacity to use it is all behind closed doors for a few massive companies is a really scary concept. So the fact that we can make Rasa and give it to people is it's something that really drives me to work more, I guess.
Yeah, and that's a great point is, as you said, because of the fact that the public face of artificial intelligence is generally bound up with these large organizations because of the fact that they have all of this customer data that they can use to train these massive and complex models, it makes it seem very foreign and unattainable for the everyday person to be able to try and even comprehend what an artificial intelligence system is or does. And by providing the tools to anybody to be able to experiment with it and see what are some of the ways that it can be used outside of these large organizations that have their own particular agendas, it makes it much more approachable and human scale and valuable to the everyday person.
Yeah, absolutely.
And what are some of the things that you have planned for the future of Rasa in terms of improvements or enhancements or new features?
So one of the things that we think would be really cool would be something that's known as reinforcement learning. So instead of you going through and hard coding in your bot, like when you have one search result, then you have to do this thing, and when you have 3 search results, you should probably list them before you do anything. What we want to do is something known as reinforcement learning. So what that is where you don't tell the bot anything, and you give it certain tasks, such as, so in the example I've just used, say you're querying an API and you get 3 different results, and it has a confidence of 0.6% is the first one. 0.6 is the first one. 0.2 it's the second one, and 0.2 it's the third one. And the bot could either sort of like take the first one or suggest all three and ask for clarification from the user. What we'd want to do is we'd want to make it so the bot could learn what the correct action would be in that case simply through trying different things out. So if the user gets annoyed after you've picked the first one because you didn't clarify and it was the wrong case, then the bot will be told, that wasn't confident enough, so you should change the model slightly. And what this means is that for like much more scalable projects that will go out to a lot of people, you obviously give it the bones of how conversations should go, but there can be specific flows within the larger flow which are tuned by simply how the user interacts with the bot, which is more like how humans learn in general and how conversations go in general.
And are there any other topics that you think we should cover before we start to close out the show?
No, I think that's kind of gone over most of them.
And so for anybody who wants to get in touch with you or follow the work that you're up to, both personally and with Rasa, I'll have you add your preferred contact information to the show notes. And so with that, I'll bring us to the picks. And let's see. My pick this week is a book that I've been reading, the Information Architecture book from O'Reilly, which is the one with the polar bear. It's definitely an interesting book. It's largely oriented around user experience design and UI information architecture, but it's definitely worthwhile to read it and consider how those same concepts can be applied to the software and systems infrastructure that we use as we're developing new projects. So it's definitely giving me a lot to think about, and I think it's worth a read. And so with that, I'll pass it to you, Joey. Do you have any picks for us this week?
Yeah, so one thing that I would recommend to anyone is a Facebook group known as Dog Spotting. So there are essentially what dog spotting is a collection of maybe, I think it's about 600,000 people now, and what they do is it's sort of like a game where if you see a dog on the street, you take a picture of the dog and then you get points for it, and then people sort of like comment on it being like, you get an extra point because the dog has a hat or something like this, and you just get the funniest stuff going on there. And it's a really good way of sort of like not looking at a Sublime screen for too long and just being able to see pictures of cute dogs. So yeah, that's what I'd recommend. And another thing which is really cool and is sort of like an illustrative thing of why Rasa is being open source is like good is that we have that somebody released an interface. Somebody sort of released an open source interface where you can label your own training data called Rasa NLU Trainer, and it means that you don't have to go through like a JSON and label and sort of like worry about where your curly brackets are, and it's really awesome. So I'll attach a link for that.
Well, I really appreciate you taking the time out of your day to join me and talk about the work that you're doing with Rasa. It's definitely very interesting, and I'm definitely going to be following up with some of the past guests, such as Obstroid and Calliope, to make sure that your work is on their radar to see if there's any way that they can benefit from it. So thank you again for your time, and I hope you enjoy the rest of your day.
Awesome. Thanks so much for having me on. It was really fun.
Thanks for listening. Don't forget to go to podcastinit.com/Linode to get your $20 credit to run your continuous delivery pipeline with GoCD, which you can download at podcastinit.com/GoCD. If you enjoyed the show, then don't forget to go to podcastinit.com/iTunes and leave a review.